Alright, so in this video, actually in the last video, I've shown you how you can make your own switch using Ubuntu 20 or Ubuntu 21 or 22 to create your own switch. A switch is basically just a series of bridges. I won't go into too much detail what a bridge is, but yeah, basically it creates one single broadcast domain, which just means that all devices within the same broadcast domain can communicate with each other without requiring any kind of routing. So basically that's your common switch that you buy, off the shelf anywhere in any, basically any store will have them these days. So that was the last video. And in the last video, Ubuntu actually uses netplan. That's a configuration utility for the network. That's a bit different than what Debian uses. So in this video, I'm going to show you how to do the same thing using Debian. In particular, we're going to be using Proxmox, which is Debian 11 based. Why? Because Proxmox can actually, it's a very simple and very elegant way to run your virtual machines, and in addition run like a switch on it at the same time. So, and your virtual machines and your physical machines and all of them will be able to communicate to each other, and the convergence point is the Proxmox server. So all the devices will basically plug into the Proxmox server, provided you have enough expansion slots, enough network cards, etc, etc. But yeah, that's kind of the point of this video. So yeah, this is the topology. I've changed it just a bit. In the last video, the S1 server was actually what's now the Proxmox. And the S2 remained the same. And now we, in addition to these two physical servers, we also have a virtual machine. It's running Ubuntu, but yeah, I wanted to show you what kind of performance you can get out of your virtual machines running this way. And yeah, the Proxmox host is a pretty powerful machine. It's an epic system with 64 cores and 512 gigabytes of RAM and a fast storage, and yeah. The physical servers are not so powerful, but powerful enough for our video. They both run two 6-core Xeons with 16 gigs of RAM, and this machine also runs 16 virtual processors, but they're actually host processors. They are being directly linked to the host, and it has 8 gigs of memory. So yeah, this is the topology, and yeah, let's see how this can be done. So in the top window is the Proxmox server. The two on the left and on the right are the physical machines, and this one, the last one, doesn't actually fit, but I will bring it up once yeah, once it's time. So let me show you first the list of the interfaces. ENO1 and ENO2 are the two integrated network adapters they're on the motherboard. They are 1 gigabit. The ENP66, those two are, I'm not using them at this point, but those are 10 gigabit SFP cards and 2 ports of the same card actually. And these two, the ENP65, those are 2 ports of the 40 gigabit Mellanox Connect X3 card. Then we have the bridge interface, and Proxmox will automatically configure a few adapters as well. That's the server. On the endpoints, we have also a number of adapters. The one that we are interested in is on the S1 machine is ENS2, and on the S2 machine is ENS3. They both run at 40 gigabit per second. Let me show you. ENS2 speed 40 gigabit, and sysclass net ENS3 speed, yeah, 40. So yeah, those are connected to ENP65F0 and ENP65S0D1 respectively. So that's that. The virtual machine has a bit different. It has only a single adapter with an MTU of 1500. So yeah, it will be interesting to see what will be the consequences of running a smaller MTU on a larger MTU network. That's possible, but there are consequences. Okay, so the configuration file on the Proxmox is etc/etc/network/interfaces. Interface without, yeah, actually in plural, interfaces. So it's a bit different than the YAML file that we used on Ubuntu to configure this, the netplan. So just a few words on Proxmox and its differences between Debian and Proxmox. So Debian, when you install it, it will just let you select one of the physical interfaces that you want to configure during installation, and it will assign an IP address to it, either statically or via DHCP, and that will be that. Proxmox, however, has a bit different installation procedure. It will ask you for your main network interface, and it will ask you for how you want the IP address to be configured. However, it will automatically create a bridge interface. So that's actually a very, very good thing, because it makes things so much easier for us. Basically, all the physical network interfaces on the machine will be manually brought up, and they will be brought up by the bridge interface. So basically, yeah, that's why we have here manual. In Debian you would see this configured differently. So yeah, the MTU has to be configured on every interface that will be on the same that will be the part of the same switch. So all the interfaces have to have the same MTU, and this has been auto configured. However, I have added a few things here. Number one, I've added the two 40 gigabit ports to be a part of the bridge. So during installation, it would have appeared, would have been configured just with EN01 as a part of the bridge. However, just add these two or any two that you desire, you know, the ones that you actually have on your system. Yeah, just add them, use and separate them by a space bar, and yeah, that's it. The bridging, the STP, the spanning tree protocol, I found it to not work really. I don't know what the problem is really. I haven't troubleshooted this too deeply, but I think it has to do something with how the virtual machines are actually accessing the network. So I think that spanning tree protocol has to be turned off. Yeah, I don't know yet, so but I will definitely research this a bit more. But for this video, we don't need to have this on. This is just a forwarding delay. 0 means that all frames will be forwarded immediately. And yeah, I use a lot of VLANs in my network, so I have configured the bridge to actually be VLAN aware. And of course the MTU of 9000. So that's it. Just edit the file and add the ports you want to use for as a switch to your /etc/network/interfaces file, and yeah, you're set. That's the server. The two endpoints don't have much. They're not much different than in the last video. Let me show you. It's netplan. There's I didn't reinstall these. I mean, it's pointless. I will just show you the netplan config. Yeah, so the two interfaces, the two ports that are 40 gigabit have MTUs set to jumbo frames, and same here, and that's it. Yeah, we can start with the fun part, which is the testing performance. So I'm gonna run the htop like in last video, so we can see what kind of an impact of performance impact running that much throughput actually has. So yeah, on the S1 I think, oh no, there is no other, okay, iperf-s address already in use. Where? I must have another screen. Okay. Oh yeah, here we go. We have another screen. Let me close this, clear, and run it again. Okay. Okay. On the, actually let's start a new window. On the other endpoint, we're going to run iperf-c 10.4.0.175 minus i1. So I'm just going to repeat again what this means. iperf is a program for generating traffic and measuring throughput. -c means that it's in client mode. Basically, it's going to connect to this address, which is this other endpoint. -i means we can specify the interval at which the program will report the bandwidth achieved. So in this case we have 1, which means 1 second. Basically it will report every second. So yeah, take a look at, so core number 1 is at 100%. we're getting 27 gigabits per second with a single stream. So that's, I think, a bit better than what we achieved in the first video, but I think if we run it again, yeah, it's not very, stable at this speed, but it does seem to have been a bit more stable. However, if we run it in a multi-stream, let's try with 4 streams again, we're actually getting a bit less throughput, total throughput, than we did in the first video. So yeah, it's not very noticeable, but it is noticeable. And yeah, in the top window you can see how much we actually are stressing the system. There is some activity, but not much. Yeah, so yeah, we're getting a really nice performance out of this. Actually, I've seen better performance running from this, but I mean, this is satisfactory in my opinion. Yeah, let's try running this same command from a VM. This window is a VM running on the Proxmox host here. So iperf-c 10.4.0.175 single stream. Let's see, single stream performance. So this is from a VM. Yeah, we're getting 22 gigabits per second, which is quite close to what we were getting here on an actual where was it? Yeah, we were getting 24 on an actual physical machine, and we're getting 22 from a VM. And let's try multi-stream. So yeah, the performance is basically capped at 22 gigabits per second, regardless of how many streams we're running. Let's run htop here and run this again, and let's see. Yeah, so it's not that it's CPU performance starved, so that's the bottleneck here. The bottleneck is probably the virtualization technique used for running a virtual network interface. Yeah, so by the way, the virtual network interface is virt.io. So this one is by far the best performing virtual interface model that you can use in Proxmox. I would use any of these other just for compatibility purposes. If this wouldn't work, if the virt.io doesn't work on some exotic system, in that case we could run Intel or Realtek or VMware. I mean, I tested this and yeah, after virt.io the best performing was, I think, Intel, and VMware, they were pretty tied, and Realtek was by far the worst performing virtual interface. Okay, so there's another way you can configure this bridge, and that's from the graphical user interface from Proxmox. Let me make this a bit bigger. If you click on the actual server and go to the network and find your bridge and double click on it, it will get you to this. So This is where you can specify your MTU. It will automatically update your /etc/network/interfaces file, and it will add the MTU value to all the interfaces that are actually a part of the bridge. So basically, all you have to do is decide if you want your bridge to be VLAN aware. That's number one. Number two, find out which interfaces you actually have on your system, what are their names, and add them here, and decide what size MTU you want to run. Yeah. If you have mixed devices, if you have older devices on the same network, do not use jumbo frames. Use jumbo frames only for high performance networks, you know, where you're moving a lot of data in and out, where, you know, for instance, your internet connection most certainly does not support jumbo frames. There might be some exotic internet service providers that actually do support jumbo frames, but they are very, very rare, and you will want to keep this at the default value of 1500. If you're using any kind of PPP, point-to-point protocol connection, the MTU will be even lower than 1500. Yeah. So yeah, I mean, it will work, but there will be a lot of fragmentation, and your router will suffer, your hosts will suffer, all of them will have to adapt to actually the lowest MTU on the network. So yeah, that's one thing to consider. So yeah, that's that. I hope you have liked this video. Please subscribe, like, click the thumb up, share. If you have any questions, please ask them below in the comments. I will be happy to explain. Yeah, I haven't decided what the next video will be, so if you have a suggestion, please post it in the comments, and yeah, see you next time.